a force acts on a cube of mass m that accelerates upwards along a vertical frictionless surface. The magnitude of the force is F and it acts at theta to the vertical. What is the magnitude of the acceleration of the cube? So we need to consider the second Newton's law, and we need to rewrite the second Newton's law in projection onto vertical axis, y-axis. You may write in projection onto y-axis or in vertical components directly, but to be more clear, let's consider all forces and then rewrite second Newton's law in projection onto a given vertical axis. So forces that act on this cube are weight or gravitational force, it's mg, and this force F at angle theta. Theta is here and also here. And there is normal reaction force, which is perpendicular to the surface, so it's horizontal and to the right. And since it's vertical frictionless surface, frictional force is 0, and the second Newton's law looks like this. F, it's a vector equation, so F vector plus n vector plus mg vector is ma vector, and to get just numbers, scalars, we write this vector equation in projection onto some axis, and we need acceleration, and since it is moving upwards and we need acceleration, and we can see the vertical axis, and in projection onto y-axis or in components, vertical components, it becomes vertical component of force F, it's this, and hypotenuse is F and this angle is theta, so this vertical component is F cosine of theta, or this force F has two components. Along y-axis it's F cosine of theta, and horizontal component it's F multiplied by sine of theta, and minus mg, and vertical component of normal reaction force is 0 because it's perpendicular. It means that it doesn't affect on motion, on the vertical motion, and is equal to vertical component of ma, and it's directly ma. It is given that it is moving upwards, so a is positive, and hence a is f cosine of theta minus mg divided by m, and it's the required acceleration. So a is correct. And if we consider in projection onto x-axis, it's not necessary here, it's additional question. You can see that it becomes n minus f sine of theta is equal to 0 because the acceleration is in a vertical direction, and its component on x axis is 0, and hence for example normal reaction force can be found, and it's F multiplied by sine of theta. And also you can see that C and D are inconsistent at all, because you can see force it's newtons minus its acceleration. You cannot subtract, it doesn't exist at all, newtons minus meters per second squared. So C and D don't exist at all. So A is correct, and that's all for this question.